Hello. Hello. Uh, Good morning, sir.
Good morning, Dr. Khamkar. I think we can start now.
Yes, sir. Yes, sir. Uh, Hello. Good morning, everyone. Myself, Dr. Mahesh Khamkar, Research Associate, Program Coordinator of this online international training program on emerging urban farming technology for vegetable production on on the behalf of Center for Advanced Agriculture Science and Technology for Climate Smart Agriculture and Water Management, Mahatma Phule Krishi Vidyapit Rahuri. On this occasion, I would like to welcome today eminent speaker, Dr. S.D.Gorantiwar, sir. Uh, Welcome, sir, Principal Investigator of CAAST-CSAWM project and uh, convener of this international online training program. And today's topic, drip irrigation system for urban farming. Uh, I would like to welcome Organizing Secretary Dr. Jayashree Pajpute Madam on this and co-principal investigator of CAAST project, Department of Agriculture Engineering, MPKV, Rahuri, College of Agriculture, Pune. And also I welcome to Dr. Mukund Shinde sir, co-principal investigator of CAAST project, MPKV, Rahuri. And also welcome to all CAAST team members, farmers, and all participants, research associate. Now I request to Dr. Pradeep Dalvi sir, uh, coordinator of this international online training program, to introduce our today's experts. Please, sir.
Good morning, all. Myself, Dr. Pradeep Dalvi, Research Associate, CAAST-CSAWM project, MPKV Rahuri. Today is our eminent speaker, Dr.S.D.Gorantiwar, who is presently working as a head, Department of Agricultural Engineering, MPKV Rahuri. Also, he is a principal investigator, CAAST-CSAWM project, MPKV Rahuri. Sir has completed BTech in Agriculture Engineering from Dr. PDK Panjarwar Deshmukh Krishi Vidyapit Akola in 1982. And MTech in Agriculture Engineering from IIT Kharagpur in 1984, PhD from Water Engineering and Development Centre, Loughborough University, London, UK, under Commonwealth Academic Scholarship in 1996. Also, sir has completed postdoctorate from Water Engineering and Development Centre, Loughborough University, UK, under Commonwealth Academic Fellowship in 2002. Sir also completed advanced postdoctorate from the Loughborough University, UK in 2006. Sir having 34 years plus experience in the field of agriculture engineering and research. Sir has received many awards. Sir has received President of India's Prize by Institution of Engineers for best paper entitled Crop Water Requirement using FAO Penman-Monteith method for Canal Command Area. Sir also received Agriculture Engineering Division Prize for best paper on evaluation of the operating policies of irrigation projects in Upper Godavari Basin in Maharashtra. Sir also received first position for Best Paper Award for estimation of the actual evapotranspiration by remote sensing methods. Sir also received Engineering Achievement Award in 2008 by the Institution of Engineers India. Outstanding Engineers Award in 2009 by the Institution of Engineers India. Sir has published 91 research paper in 21 international and 72 national journals, out of which NAS rating is more than 6 is having 25 papers. Full length research papers in the proceedings of the conference having 90 papers sir has published. Out of them 18 papers in the international proceedings and national 72 papers in the national proceedings of the conference or seminars. Sir has written 12 books, out of them 6 international books and 2 national books. Review paper in international journals having 1 review paper in international journal, and sir having published 12 book chapters. Sir has developed different technologies for crop coefficient of different crops, irrigation and fertigation scheduling for different crops, yield response factors, polyhouse and shade house cultivation for different vegetable crops and flowers, evapotranspiration, water requirement and irrigation water requirement for different crops, deficit irrigation for different crops, soil water balance, crop yield simulation models, software for designing of the drip irrigation system, adoption of drip irrigation on canal command area, estimation of the reference evapotranspiration and farm fund design, web-based mobile application for estimation of reference evapotranspiration, irrigation scheduling, weather data input, and retrieval of the system. Sir also developed technology for the drainage coefficient for different soils and return rates. Decision support system for irrigation water management and also groundwater recharge. Sir is a member of many national and international level committees, member of QuinQL reviewed QRT for the Indian Institute of Water Management Bhubaneswar and AICRP on irrigation water management since 2000 between 2012 to 17. Sir also member of the QRT for the Central Research Institute on Dryland Agriculture, Krida, Hyderabad, and AICRP on Dryland Agriculture and AICRP on Agricultural Microbiology during 2012 to 17. Sir also member of State Level Committee on Micro Irrigation since 2010. Also State Level Committee on Protected Cultivation since 2010. Sir also member of the committee on State Level Committee on the adoption of drip irrigation on canal command areas in Maharashtra since 2016. Sir also member of National Project on Aquifer Management State Groundwater Coordination Committee since 2017. Sir also advisor from MPKV Rahuri for project on climate resilient agriculture, POCRA. Now this POCRA is renamed as Nanaji Deshmukh Krishi Sanjeevani Project, Government of Maharashtra. And sir is working as advisor from Science 2016. Sir also representative of Honorable Vice Chancellor MPKV Rahuri on Board of Governors, Water and Land Management Institute, Valmi, Aurangabad since 2010. Also PMKSY, which is government of India, Pradhan Mantri Krishi Sinchay Yojana in Maharashtra since 2016. Sir also has done many research projects. Sir was in charge in administrative and technical control of AICRP and optimization of groundwater utilization during 2019 to 2006.
Thank you,
Sir also
Dr.
generated the
Devi.
funds within the departments through externally funded research project as principal investigator and also co-principal investigator. Sir has completed 5 research projects and 3 ongoing projects are there at MPKV Rahuri. Sir also participated in the finalizing research priority areas and developing research. Now I request Dr. Gorantiwar sir to please start session.
Thank you, Dr. Devi. Can you listen me?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Thank you very much for my long elaborative introduction. I thought probably this lecture is for my introduction or what. Okay. So you are not supposed to give such a long introduction of ourselves. I think you note for the future. Okay. Very good morning to all the participants of this training program on the urban farming. And I would like to especially mention Honorable Vice Chancellor Ruhiya Dahiya Madam, and as well our ex-student engineer Nilesh Khare, who is also here, and there may be many more experts as well. Okay?
Very good morning, sir. Nice to meet you, sir, and looking forward for your lecture, sir.
Okay, thank you.
Thank you very much, sir.
Madam. Yes, thanks a lot. Yes, thank you. Yeah. And this, my lecture is on drip irrigation method. I found that some of the participants, they are already expert in the drip irrigation method. Okay. However, some may not be actually. Okay, but still I keep my lecture at a very basic level because the intention was to give or to provide the flavor of drip irrigation method to those who don't know much about drip irrigation method, and at the same time I would like to cover sprinkler irrigation method as well. Okay, so as I have retitled my lecture as modern irrigation methods, drip and sprinkler. Okay. Now, first of all of us know that why irrigation is required. Okay, But let me substantiate this with certain data. Okay, there is one particular slide on the screen of your laptop or mobile. I hope you are able to see that slide. Okay, and the first what we call as the graph is our map of India, which shows the spatial variation of the rainfall. Okay, spatial variation of rainfall means variation of rainfall along with the location. Okay, so that we call as the spatial variation of rainfall. Now, if you see, the rainfall varies over our country quite greatly. Okay, so it is as less as 25 millimeter per year in part of Rajasthan, okay, to as high as more than 10,000 millimeter per year in Western Ghat and in the eastern states. Okay, such is the variation actually. So 25 millimeter to more than 10,000 millimeter is great variation. So this means that in some part of India we don't get enough rainfall for the crop growth, and in some part of India the rainfall in excess actually. Okay, at the same time the next graph shows us the temporal variation. Okay, variation of the rainfall with respect to time. Okay, so this is called as the temporal variation of rainfall. If we divide our entire year into 4 quarters, one is say winter season, January, February, another is pre-monsoon, March to May, and third is say monsoon, June to September, and fourth is post-monsoon, October to December. Okay, so these are the 4 quarters. So then we can see that almost 90% of the rainfall is received in monsoon season. Okay, and rest of the 8 months receive only 10% of the rainfall. So this we call as the temporal variation, that is variation of rainfall with respect to time. So first we have seen the variation of rainfall with respect to location. Okay, so location to location rainfall is varies quite greatly. Time to time at particular location also rainfall varies greatly. Okay, and at the same time, if we see there is one graph actually. So in this graph, if you see, there is one red line which is the water requirement of particular crop. Say this is the annual crop and this is the water requirement of sugarcane crop. Okay, and you see blue line, so this is the rainfall. Okay, so what you can see, the rainfall falls over only say monsoon season for 4 months. Okay, however water requirement of crop is for the entire 12 months. Okay, plant needs water for entire 12 months. Okay, but we receive rainfall over only 4 months. Okay, so all these facts substantiate the need of irrigation actually. So first thing is that, okay, so just like us, plant needs water for its entire growth season, and normally the direct source of water for the plant is rainfall actually. Okay, so if rainfall is received over entire plant growth period, okay, then we may say that there is no need of rainfall. So it happens in the Mediterranean region or say southern part of the Europe. Okay, so wherein normally 3 to 4 mm rainfall is received almost every day. So there may not be necessity of irrigation because rainfall is the natural source and it meets the plant water demand. Okay, but in country like India, when we receive rainfall only for 4 months and for remaining months, really there is a necessity of providing water to the plant, and that necessity is satisfied by irrigation. So there is the purpose of irrigation. So why we need irrigation? Because of the temporal variation, and also because of spatial variation, because in some part of country the rainfall is less than excess, and in some part of country rainfall is much more than required. It is in excess actually. So we have to divert the stored water of the rainfall from the part which has excess rainfall to the part which has deficit rainfall. Okay, and also we have to satisfy the needs during the period when there is no rainfall. Okay, so this particular fact substantiate the need of what we call as irrigation. Then why we have to do all those things? Because we have to manage. So once we know that there is a need of irrigation, because though I tried to explain in elaborately, but many of you know that because there is no rainfall during 8 months in India, okay, and plant needs water during those 8 months as well. So we have to apply water to the crop artificially, and that we call as the irrigation. Okay, but then why we have to manage this? We have to manage this because we have to store this excess water somewhere. Okay, so during 4 months we receive more water. Okay, so which is more than the plant water requirement actually. So that water flows in the rivers. Okay, that water percolates into the groundwater. Okay, so we have to store all this water. Okay, so when we have to store means then all kinds of the management practices we have to adopt. Okay, for example, the water in excess when flows over the land surface, we call this as the runoff, and that runoff meets to the river through nalas and what we call the drains. Okay, and if we don't store that by having certain reservoir, that will normally flow into the sea. Okay, so then it is not useful to us. Okay, secondly, some portion of the rainfall which falls over the land surface will also infiltrate into the soil, and it will be stored somewhere into the groundwater reservoir. Okay, and which we can ultimately use. Okay, so this excess rainfall we have to store if we have to use those properly in the months when there is no rainfall, that is the remaining part of the year, 8 months. Okay, so what we do then, we build the different kinds of the surface reservoirs. We store water in those reservoirs. Okay, and then we divert the stored water from the reservoir into the field. Okay, that we call as the irrigation. At the same time, we allow more and more water to infiltrate into the soil, so that this water is stored underground. We call those as aquifer or groundwater reservoirs. Okay, and then we can pump that water whenever we need during 8 months. And at the same time, the water which is stored in big reservoir, okay, is diverted into the region where there is very less water and no provision to store water. For example, much part of the Rajasthan is irrigated by the canal which emerges from Punjab and Himachal Pradesh. Okay, because we store water there and we divert that water to the part of Rajasthan. Okay, so this takes care of the special variation of the rainfall, and also when we store water overground or underground, this takes care of the temporal variation of the rainfall. But when we say that we have to store water, we have to divert water, we have to apply water, then all sort of the management techniques we have to apply, and therefore we have to manage water, and therefore we have coined the word water management. Okay, and the next question comes, why this water management needs to be efficient? Okay, because it is not like that. Whatever the excess water is there, we have stored water, and let us divert that water whenever it is needed and wherever it is needed. Okay, but we have to do this efficiently. And why? Of course, there are many reasons for that. But one reason I would like to point out that the first histogram, many of you might have seen this histogram already actually. Okay, I hope Dr. Darvi, can you confirm whether you can see the slides properly? Dr. Darvi.
Yes, sir.
Mohsin, you have to
Yes,
respond
sir.
quickly, whether you can see the slides clearly.
Yes, sir. Yes, it's
Okay.
clear, sir.
And ask Darvi to be there.
Yes, sir. Yes, sir. Okay.
So the first, if you see the first histogram, okay, then it shows the water availability in cubic meter per capita per year. Okay, what is water availability actually? So this water availability during 50s was 5,000, and this water availability now almost decreased to 1,500 meter cube per capita per year. Actually, this is from 5,000 to 1,500. This is because of mainly two reasons. One, because of the growth of the population, and second, because of the requirement of the need of water for many purposes. Actually, okay. So because of these two reasons, in fact, the water availability in India is going down. So during independence, it was 5,000 meter cube per person per year. Now it has almost dropped to 1,500 meter cube per capita per person. Now, what is its implication? The implications, they are like that. Okay, I have shown two lines. One is water stress line, and next is the water scarcity line. Okay, so water stress line is the line where water availability is around 1,700 meter cube per capita per year. Okay, and if water availability of any region is less than 1,700 meter cube per capita per year, then we say that that region is now water stressed. Okay, the second line is 1,000 meter cube per capita per year availability, and this we call as the water scarcity line. Okay, so this means that whenever the water availability of any region, okay, decreases or becomes less than 1,000 meter cube per capita per year, then we call that region is now water scarce. Okay, so this is the importance of these two water stress two lines actually. Okay, one is 1,700 meter cube per capita per year. So when water availability goes down beyond this limit, then we call this as the water stress line, and we call this region as the water stress region. But when it still goes down, say water scarcity or water scarcity line. Currently, we are at 1,500 actually. Okay, and it is expected that we may touch to water scarcity line in future. Okay, and when our water availability goes down below the water scarcity line, then this is called as the alarming situation, and it also influences the overall growth of the region actually. So then our purpose is that we should not able, or we should not make anything by which we push below the water scarcity line. But currently we are in that zone, and so there is, and therefore we need the efficient water management practices. Okay, so that our water availability doesn't go below the water scarcity line. Okay. Then another reason why it should be efficient, of course, there are several reasons why it should be efficient, but I'm pointing out certain overall reasons actually. Then there is histogram as well, which is horizontal. It shows the sectoral use of water percentage wise. Okay, there are basically three sectors. Okay, so which need water, which consume water. One is the agriculture sector, which is shown in green line. Another is domestic use, which is shown in blue. And third is the industry, which is shown in brown. So these are the three sectors which generally need water. Okay, so agriculture, domestic, and industry. And on this y-axis, we have shown the continents: Africa, escape country, so wherein our Southeast Asian and Pacific countries come. Then Latin American countries, then North American countries, and European countries. If you see, of course, this particular figure is for around 2000. In Africa and Southeast Asian countries, more than 80% of water is used for irrigation, that is for agriculture. Okay, and less than 7 or 8% of water is used for industries. And vis-a-vis, if you take North American and European countries, less than 40% of water is used for agriculture, and almost 50 to 60% of water is used for industries actually. Okay, so this is one picture, and here I have shown country wise as well. Okay, so if you see, India consumes almost 85% of the water for agriculture, and 78% of water for industry. Okay, and whereas Russia use almost less than 20% for agriculture, and 60% or 70% of water for industry. China, which utilizes almost 70% for agriculture and 25% for industry. But this is 2000. Now China's figure for utilization of water for agriculture has gone down to 50% actually. Okay, but have you ever heard that these countries north there are deaths due to the starvation and all those things? We didn't. Okay, of course there are many reasons, but one of the reasons is that these countries invest heavily in the infrastructure, water infrastructure, and because of that they are able to use water efficiently. And when they use water efficiently for agriculture, they can make water available for the industries as well, because industries is also the backbone of the economy of several or almost all the countries. Okay, so in India as well, if we are able to invest on the water related infrastructures heavily, okay, so that farmer can use the water efficiently for agriculture, and farmer can make water available for the industries, and it will not only flourish our overall industry, but also for the agro industries as well. Okay, so when agro industries they are flourish, then at the same time, okay, agriculture will also flourish. Okay, so therefore what we always advocate that we have to use water efficiently, make water available for other sectors, and for utilizing water efficiently there is need for the investment in the water related infrastructure. Okay, otherwise how one can use water efficiently? Okay, so and some of the means which I am going to tell during my lectures, they are related to the water related infrastructure. Okay, now these are the typical water has to be stored somewhere. Okay, so normally this is the right hand side shows the big reservoirs where we can store the water across the rivers. Okay, and from the big reservoir water is taken into the canal network. So this is all the canal network. Say this is the main canal, then this is the distributary, then this is known as the minor, this is the field canal, and this is the field. Okay, so we need such kind of the infrastructure actually to take water to the field from where water is stored in the reservoir. Okay, alternatively, if you see the left side, okay, then this is the farm scale actually. Okay, so this is the large scale wherein when we store the water in the dam, millions of the farmers are benefited because of the diversion of the water from the reservoir, but we need such a huge infrastructure as well. Okay, then another is the farm scale actually. On farm scale also farmer can store water into the small reservoir. Okay, so which we call as the farm pond. Okay, and then with the help of the small network, maybe pipe or pumping from the reservoir, or maybe small field channel, the water can be brought into the field and can be applied by certain means over the field. Okay, and third is the groundwater actually. Okay, so if you see here, this is the water which is sprayed over the ground, and this water then percolates into the groundwater reservoir, which we call as the aquifers, and from aquifer through small network it is taken into the field, so where water is applied to the field. So what you see from this, when we have to apply water during the 8 months artificially to the plant, okay, or when we have to apply water or when we have to apply or divert water to the locations where there is very less rainfall, then we need all kinds of this infrastructure actually. We have to invest in this infrastructure. These infrastructures, normally they are the infrastructure which exist in our country. Okay, but these infrastructure provide just water to the field. Okay, but when it comes to the field, there is necessity of using this water efficiently. Okay, so this is very essential. So one study shows that out of say 100 unit of the water which is stored in the reservoir, okay, only 30 unit of the water reaches to the field. Okay, so this means that 70 unit of the water is lost somewhere. Out of this 70 unit of the water, almost 30 to 35 is lost in the process of this conveyance, and 30 to 35 unit of the water is lost when it reaches to the field. why we are going to see, and this is in fact the major topic of discussion today. Okay. So before that, we'll just see there are several. Then one such means is that by adopting proper irrigation scheduling. So for example, I showed in the previous slide that when water is brought from the reservoir to the field through the network of the canal. So one of the ways to use water efficiently is why not to supply this water through the network of the pipes to the field, so that that all we can save all this 30 to 35% of the water. Why not to the channels? Okay, so this is one of the options. Okay, so there are several such options actually. Okay, and out of those several such options, irrigation scheduling is one such option actually. Okay, irrigation scheduling means when water reaches to the field, then we have to decide how to irrigate the field. Okay, then when to irrigate the field and how much to irrigate the field. Okay, so normal practice which was being practiced previously, that is when water reaches to the field through the network of the canal, just allow water to spread over the field. That we used to call flooding actually. Okay, so if we adopt that practice, almost 70 to 80% of the water is lost actually. Okay, either in the tailwater runoff or either in excess percolation. Okay, so that's what then we have to see how we have to apply water to the field. Then this is called as the how to irrigate, and this is irrigation methods actually. And once we decide what is irrigation method, then we have to decide when to irrigate. Means when we have to apply water to the field, whether we have to apply water daily, whether we have to apply water after 1 month, after 2 months, after 15 days, after 7 days, that we have to decide. That is what is the irrigation frequency. This is known as the when to irrigate. And third is how much to irrigate actually. Okay, that is when we have decided that we have to irrigate the field by say sprinkler irrigation method once in a week. Then we have to decide how much water we have to provide to the field once in a week. So this is how much to irrigate. Okay, so as I again repeat, there are several options for saving the water. So two options I already told. Say for example, supplying water from the reservoir to the field by pipe network or by providing the water canals. Okay, but when it comes to the field, then also there are several means to use water efficiently. And one of those is by adopting the irrigation scheduling. Irrigation scheduling means just answering 3 questions efficiently. How to irrigate, that is when water reaches to the field. Then how to spread to the field is known as how to irrigate, and this is governed by the irrigation methods. Okay, then when. Okay, so whether 2 times a day, once in a 2 weeks, once in a month, like that. This is known as when to irrigate, irrigation frequency. And third is how much, that is at every application how much water we have to provide. Okay, let us first target on how to irrigate actually. Okay, so this is known as the irrigation methods. Okay. Normal practice of applying water to the field, as I told you, that just to allow water to spread over the field, and because of the gravity or because of the certain head provided, water will randomly move over entire field. Okay, and then water will percolate into the soil or into the root zone of the crop, which we call as the flooding. And flooding wastes a lot of water. Okay, so then instead of flooding, such as border, this is the border actually. In border, what happens? We lay the strips of certain width, and then we allow water to flow in between those 2 strips, so that the water moves swiftly over these strips, because we also provide certain slope. Okay, so this is known as the border irrigation method. Instead of these 2 strips, we can form the ridges and furrows. Then this is known as the ridge and furrow irrigation, or there may be the basins like this. Okay, so these are called as the surface irrigation methods. Okay, the first was flooding, that is just to allow water to flow in the field randomly, so it will move wherever it finds its path. Okay, depending on the slope, okay, or depending on the depression or ups and down. So in that process, water won't be applied uniformly. Somewhere excess water will be applied, somewhere no water will be applied, but this we call as the flooding, and in this process 60 to 70% water is lost. So instead of flooding, if we level the field and provide certain kind of the layouts, say such as this is the check basin layout. So while farming the layout, we have to provide certain slope to the field. Then we have to have a certain provision to guide the flow of water over the field, and those we call as the layout. Say for example, if we want to describe this border irrigation, so water is allowed to flow in between two strips or in between two ridges actually. Okay, so these are used for the containment of the water. As water flows over the surface, some of the water will infiltrate into the root zone of the crop like this. So here the water is infiltrated into the root zone where it is needed, and some of the water will flow ahead, and while some of the water flows ahead, this water will also be infiltrated into the root zone. Okay, so in this way the irrigation will be affected. Let me tell you one fact for those who don't know. Giving irrigation means applying water into the root zone of the crop. Of course, this is not true for hydroponics or aeroponics. This is for the general irrigation or when we use the soil media. Okay, so when we have to allow water to flow over the land surface, so while water is being moved over the land surface, some of the water will be infiltrated and some of the water will move ahead, and this infiltrated water, in fact, into the root zone, we call this as the irrigation. Okay, then these are known as all surface irrigation method, border, surface, border, check basin, and ridges and furrows. Then there are some modern irrigation method, okay, which we call as the sprinkler irrigation method. Okay, in sprinkler irrigation method, what happens? Water instead of allowing to flow over the land surface, water is brought to the field through the network of pipe, and in the field water is allowed to spray over the crop in the form of rainfall, as you see in this first picture actually. Okay, here the water is brought in up to the field, okay, under pressure, okay, through the pipeline, and when it reaches to the field under pressure through the pipeline, then with the help of the nozzles, water is allowed to spray over the field in the form of rainfall actually. Okay, just means it is basically it is simulating the rainfall. Okay, so this is known as the sprinkler irrigation. As you see, this is the sprinkler irrigation. This also is the sprinkler irrigation. So in this method, what happens? In surface irrigation method, what we do, from say well or reservoir, we allow water to flow through the network of the canals, and then we bring water to the field, and we allow water to move over the land surface. So much of the water is lost in the network of the canal, and some of the water is lost when it is flown over the land surface. But in sprinkler irrigation method, what happens? We bring water up to the field through the network of pipe under pressure, so there is no seepage losses, no percolation losses up to the field. And when it reaches to the field, water in fact is sprayed into the field in the form of rainfall, just simulating the rainfall, so it gets the rainfall effect as well. So in that process, we can save water up to 25%. This is great amount actually. Okay, and also because it provides us certain what we call as the rainfall effect. Okay, and because there is the possibility of applying water frequently to the field, we can also increase the production or yield by 10 to 20%. Of course, there are several versions of the sprinkler irrigation. So this is known as the conventional sprinkler. Okay, for those who don't know, these are the sprinkling nozzles. So there are different kinds of the sprinkling nozzles. Okay, so in this method, this is the pipe which is laid over the field, and this pipe can be connected quickly. Over this pipe, there is this riser is mounted like this, and over the riser there is nozzle, and under pressure, when water is supplied through the network of the pipe, then this nozzle will spray water in the form of the rainfall. So this is in general the principle of the sprinkler irrigation method. So these are the nozzles. Okay, this is just details of the nozzle. Then what happened in conventional sprinkler irrigation? If we have say 1 hectare field to irrigate, then instead of having the entire sprinkler irrigation method for 1 hectare field, because it becomes expensive, we need too many network of the pipe, and at the same time we need too many nozzles. Okay, so instead of that, what we do, we design the sprinkler irrigation system in such a way that we need the set only for the part of the field. Okay, say maybe 1/4 hectare, and then we apply irrigation to first 1/4 hectare first quarter. Then we move that set from one quarter to second, second to third, and third to fourth. Okay, so in that way we save on the cost of the system actually, because this system cost quite extensively. Okay, but in that process, what happens? We have to move the sprinkler set from one place to another, and this is quite cumbersome. So then many of the farmers they say that we don't want the system to be moved, and still it be cheaper. Then for that the alternative is to adopt the mini sprinkler. So mini sprinkler is the smaller version of the conventional sprinkler, so which is cheaper as well. So wherein we can lay the entire sprinkler system over 1 hectare of the area, so that there is no necessity of moving the set from one portion to another portion. And exactly opposite to that, there is one system which we call as the rain gun. Okay, so conventional sprinklers, then mini sprinklers, and rain gun. So it is quite possible that we have to irrigate only the entire our piece of field only with the help of one nozzle. So it is possible. Okay, so these nozzles, they are very big nozzles. Okay, if you see here, you see the jet which is coming out of the nozzle, and it is being broken in the form of this spray. Okay, this particular nozzle can irrigate up to 1 hectare area in one go. So these are called as the rain gun. But to have the spray of water to irrigate 1 hectare of the land, we need a lot of flow, and at the same time we need a lot of pressure, means a lot of energy. Okay, but nevertheless, if there is any farmer who wants to irrigate the entire his or her field, maybe 1 hectare, 2 hectare, then that farmer can use the rain gun, but it needs high pressure and high discharge as well. These are very heavy nozzles are used for this purpose, you see, and that's why these are known as the gun. Okay, and the next version of the sprinkler irrigation is the central pivot system, which is not practiced in India. Okay, but where there is plenty of the land. Okay, and wasting some of the land doesn't matter, and where land holding is also quite large in the sense that we can grow one crop over thousands of the hectares of the area, then the central pivot system is used actually. Okay, in central pivot system, what happens? There is one long arm actually. So if you see in both the left hand side photos, this is the long arm. Okay, so these are the arm. So on this arm, the nozzles are mounted, which are inverted towards the land surface. Okay, the nozzles are mounted on this. Okay, and this arm is moved in 360 degrees, and while this arm is moved, the nozzles provide water over the canopy of the crop. Okay, and as it is moved, it covers the entire surface, and in that process it forms such kind of the circle actually, and the area of this circle can be as high as 25 hectares to 100 hectares, means in one go it can irrigate 25 to 100 hectares. So this kind of the irrigation practice is normally followed in Central America and the countries like Brazil, Australia, and Argentina, where there is quite large land holding, and one farmer is having the large holding up to 1,000, 2,000 hectares, and that farmer can take only one crop, say maize or wheat. Okay, so that there is no necessity of having the different irrigation scheduling for different crops. So we can have one irrigation scheduling, that is when to apply and how much to apply. Okay, and even those who have traveled from what we call as the eastern part of the USA to the western part. So during central region, when we just peep down through the aeroplane window, then we see such kind of the circles there. So those circles are being irrigated by the central pivot system. Nowadays, of course, there is also one modification into that. That is when the central pivot comes to this corner like that, there is one extra arm is provided so that the dry area which we see here now, this is also irrigated. Okay, so that the entire land is used efficiently. Okay. Then now, but still sprinkler irrigation methods use what we call the need a heavy flow, energy and all those things. Okay, it saves of course 25% of the water. But the need of saving water, utilizing water more efficiently also arises, and for that we have to adopt the micro irrigation method, and drip irrigation method is one such micro irrigation method widely adopted, practiced in over the world, and particularly in the state like Maharashtra, then what we call Andhra Pradesh, Telangana of India, and worldwide as well. Okay, normally this system originated from the country Israel, so it is practiced in Israel almost over the entire land, in major part of USA, and in many Mediterranean countries, Australia, and many Gulf countries, and including countries like India, Pakistan, and part of China as well. Okay, so let us see the mechanics behind this drip irrigation system. First, let us see why we need the drip irrigation system. Okay, because just like sprinkler irrigation system, drip irrigation system also need the infrastructure. As we saw in surface irrigation method, it doesn't need the infrastructure much at the farmer level, of course. At the collective level, it needs. Okay, but when water comes to the field, then farmer has to just allow water to spread over the field, and that's all. But in case of sprinkler irrigation method, drip irrigation method, when water comes to the field, then we need to have certain kind of the infrastructure to apply water to the field. Just like in sprinkler irrigation method we saw, we need the network of the pipes, okay, and also nozzles, and also we need the pumps to supply water with the pressure. So this is all the infrastructure which farmer has to invest actually, and its cost is also quite high. So farmer needs to be provided with certain means to offset for that cost, and of course governments provide certain financial assistance on these methods as well. Similarly, in drip irrigation method as well, okay, when we have to apply water to the field, it needs certain infrastructure, okay, at the farmer level, and farmer has to invest for that. Okay, but then first thing is that why farmer, or why we should go for these irrigation methods? There is reason for that. Okay, so one is its water requirement. Okay, so if we compare this with the surface irrigation method, this green histogram is surface irrigation method. If surface irrigation method needs 100 units of water, then drip irrigation methods need only 50%, 50 unit of the water. That is, the water requirement by drip irrigation method is almost 50% less than the conventional surface irrigation method. Okay, and because of which there is saving of water to the extent of 50%. If we adopt drip irrigation method vis-a-vis the conventional irrigation method. At the same time, there is saving in chemicals, fertilizer. If surface irrigation method needs 100 units of the fertilizer, drip irrigation method only needs 75% unit, because in surface irrigation method what happens, we can apply fertilizer only with every irrigation. Okay, or we apply fertilizer only 2 to 3 times, because when we apply the fertilizer, we have to apply water. And in case of surface irrigation method, the frequency of application is not much because of its peculiar nature. Okay, and also in surface irrigation method, water is lost in the form of percolation, and with water, the fertilizer is also lost. Okay, but in case of drip irrigation method, we have proper control over the fertilizer. Okay, because we have proper control over water. Okay, so there is fertilizer requirement is also reduced, and therefore there is saving of fertilizer to the extent of at least 25% if we adopt the drip irrigation method over surface irrigation method. And as all of you may be knowing that our country spent, or many countries spent a lot of money on the fertilizer, and if we save 25% of the fertilizer, it is large saving. Then increase in yield. It is not only the saving in the resources like water and fertilizer and land, but at the same time we get more outputs as well. Okay, say if we get the 75 units by surface irrigation method, then drip irrigation method provides 100 units. So there is increase in yield to the extent of 25%. Okay, and at the same time we can bring additional area under irrigation, because when we save the 50% of the water by drip irrigation method, and if we have additional land, then we can irrigate the additional land with the saved water. Okay, so that is almost double, and because of that we get almost 50% more net benefits because of this drip irrigation method. And there are several other advantages as well. Weeds. Okay, surface irrigation method, where there is a lot of weed infestation and we have to apply a lot of chemicals to control weeds. But in drip irrigation method, it is less than 50% of the weed infestation that happens compared to that happens in surface irrigation. Labor saving. Okay, so drip irrigation method can save a lot of labors, and there is possibility of perfect automation in drip irrigation method. We are working on that, so that the labor requirement is much reduced. So I have here shown 50% that is currently at the farmer level, but we can bring down that labor requirement to the 10% compared to the surface irrigation. So there is labor saving. Then there is more scope for automation in drip irrigation method, as I already told. And by drip irrigation method, we get quality product. The reason is that because of drip irrigation method, we can apply exact amount of the water which is required by the plant. Okay, and whenever it is needed. Okay, so unlike in surface irrigation method, we have to apply water as per the characteristics of the method. But in case of drip irrigation method, we can apply water as per the need of the plant, and therefore we can get the better quality product. Okay, but still its adaptability is quite poor in many countries. This is because of the high initial cost compared to the surface irrigation method. Then in many countries, say barring few countries, lack of technical know-how. Okay, because this is normally the first or second generation of the farmer who are using drip irrigation method. And and as far as the surface or other conventional practices, it is almost maybe 100 or 1000 generation, and knowledge is passed from one generation to next generation on other conventional practices. Okay, but when we say that to adopt the directly drip irrigation method to first generation farmer, then it becomes difficult. So there is lack of technical know-how, and for that we have to provide the training to the farmers, training to the trainers, and as well we have to give the support to the farmers for drip irrigation method. Okay, so these are the some reasons because of which there is less adaptability of drip irrigation method in many countries actually, even after realizing the importance of a drip irrigation method in saving up the resources, and also in what we call as enhancing the output in terms of yield and in terms of the benefits as well. Okay, so as I said, % of the water with increase in yield up to 20 to 50%. Here I would like to describe the one layout of the drip irrigation method. So this is the entire drip irrigation method. As you see, this is the network of the pipe. Okay? And this network of the pipe is in the field actually. So this is basically field. You can see the what we call as the plantation here, small crops. Okay, and you see for each row of the crop one pipeline is there. Okay, and then these pipes, they are connected to one more pipeline, and this is also connected to another pipeline, and finally it is coming to the well. So I would like to describe this in detail. Okay, so in drip irrigation method, what happens? Applying water to the root zone of the crop, because a crop takes water from the root zone actually as per its requirement. Okay, and wherever it is needed. Okay, so for example, we ourselves also has certain requirement of the water. So plant has also certain requirement of the water. So we have to apply water as per the requirement of the crop. Okay, and where we have to apply water, we have to apply water into the root zone, because crop roots, okay, they are in the soil root zone, and those roots take water from the root zone to the plant. Okay, and we don't have to apply water anywhere else. Okay, only into the root zone. Okay, so if you see, this is the row of the crops. Okay, and then there is certain wetted portion. So this is the root zone actually. Okay, so in drip irrigation method, what happens? Okay, the water is brought from this water source, okay, up to the root zone, and at root zone it is applied to the crop in the form of the droplets. Okay, and for that we need certain network of the pipe. I just call those as the pipes for the time being. Okay, but if we start from the end of the field, okay, then you see that there are certain buttons kind of the thing is shown. So those are known as the nozzles. Okay, those are known as the drippers. The purpose of the dripper is that to allow water to flow in the form of droplet, or to allow water to ooze in the form of droplet over the land surface. Okay, so that's why it is called as the drip irrigation method. Okay, so these drippers allow water to fall over the land surface in the form of the droplets, so that when one drop falls over the land surface, it immediately infiltrates into the root zone of the crop. Okay, so there is no excess water. Okay, so whatever whatever the requirement is there, we can apply, because water is applied in the form of the droplet. So all those drippers are emitters. Okay, so they are mounted on one pipeline which is called as the lateral line. Okay, so this pipeline is called as the lateral pipeline. Okay, so there are several lateral pipeline, okay, for each row of the plant. So many a times it is not necessary to have each row of the plant, but for the time being, you please remember this. And then all these lateral pipes, they are connected to another level pipe which is known as the submain. Those who are new to the drip irrigation system, these are the nozzles which are mounted on the laterals. Then the laterals, they are mounted on the another pipeline, next level pipeline, which is known as the manifold, or what we call as the submain line. And then this submain line is connected to the main pipeline. Okay, why this is called as the main pipeline? Because such kind of the submain unit may be in the field over a large area. That is, say, if this is the one corner of the field, this may be another corner, then there may be more corners of the field. So each corner will have one submain. So this is also called as the subunit. Okay, so all these subunits or submains, they take water from main pipeline. So this is called as the main pipeline. Okay, and from main pipeline, okay, main pipeline is connected to the filters and also fertilizer application unit, and then to the pump, and pump takes water from the water source or well. Okay, now I will tell in a reverse way also. Okay, so this is the water source. Okay, and from water source, water is pumped through a device which is called as the pump. Okay, and if you see here, there is one bypass arrangement. Okay, because what happens, sometimes we have to apply less water, sometimes we have to apply more water. Okay, in the field, depending on the crop water requirement. Okay, every time water requirement is not less. So some of the water we have to bypass, okay, into the water source itself. So therefore there is bypass arrangement. Okay, this is just to bypass the excess water. It is quite possible that at one time I am irrigating this field, and at another time I am irrigating another field. So another field's area may be large compared to this field area. So we have to have certain bypass kind of the arrangement, okay, so that we can pass only required amount of the water into the system. Okay, so that's why this is known as the bypass one. Okay, then from when say excess amount of the water or unwanted amount of the water is bypassed, the required amount of the water is taken into the pipeline, and there is one valve which is called as the non-return valve. Okay, so this non-return valve allows, okay, not to flow back the water into the pump. Okay, so if some of the water by chance, because of the say immediate closure of the system or sudden closure of the system, some of the water will flow back, and if this water falls over the pump, then pump impeller, in fact, then the pump impeller of pump will be damaged. Okay, so that we have to restrict that water, and for that there is this non-return valve. Okay, so that non-return valve arrests the water or prevents the water going back to the field in case of the sudden closure. Okay, so this is non-return valve. Then from non-return valve, the water comes to the filter actually. Now there are several kinds of the filter. Some of the filters, they are optional. So this is known as the hydrocyclone filter. Why these filters they are necessity? Because this is hydrocyclone filter. This is known as the media filter. This is known as the screen filter or disc filter. The reason is that when water comes to the field, okay, then this water is emitted in the form of droplets through the nozzles, and these nozzles, they have small holes actually. If water is with certain impurity, then what will happen? This impure water will tend to block these nozzles, and certain portion of the field may not get water actually. Okay, so to prevent this, we have to have certain kind of the filter. So this is known as the hydrocyclone filter. So for example, if in the water source, if the water source is from the river actually, okay, then river carries lot of sand. Okay, if that water with sand comes into the system, naturally it will block our network of the pipe and also the nozzles. So hydrocyclone filter is there. So hydrocyclone filter removes sand. I may not tell you the principle because it may take time, but it removes the sand from the water. Okay, and sand-free water will come into the system. So normally when we have water source from well like this hydrocyclone filter is not necessary. But when we take the water from river, then it is necessary. Then from this water is coming into the media filter actually. Okay, so for the time being, I'm not telling you about the fertigation device. This is known as the media filter. Say for example, media filter means basically this is big tank, and in big tank there is sand actually. Okay, this sand is different than the sand in river, which I call this as the impurity. Okay, so by chance if there is the organic impurities material like that, say algae or leaves and all those things, okay, so hydrocyclone filter cannot arrest those, so those will pass into the system. But if those pass into the system will block immediately. Okay, so if we have sand filter, then when water is allowed into the filter, and water will pass through the sand bed, and when water is passed through the sand bed, then the organic impurities will be separated, and these algae or leaves and all those things, free water will come into the system. And then there is what we call as the screen filter or disc filter, and it will remove the remaining impurities. Okay, so impurity free water will come into the system, and there is again one non-return valve, and there is one valve which will control the flow over this what we call as this particular subunit. Okay, so the main purpose is to bring the impurity free water into the system. Even if our source of the water is say distilled water, then still we need one kind of the filter, which is the disc filter or what we call the screen filter. This sand filter is only necessary when there is possibility of algae or leaves into the water source, and this hydrocyclone filter is necessary when the sand is into the water source. Okay, so then fertilizer is applied with the help of fertilizer device, which is known as venturi or fertigation pump, and this is installed here. Then water without impurities and with fertilizer will come into the main system, and from main system it will come into the subsystem, that is the manifold, and on each side of the manifold the laterals they are sprayed, and from lateral water will come into the will fall over the land surface into the root zone in the form of droplets, and this is called as the irrigation. In that process, if you see, there is the dry portion in between two rows because water is not required there, and this is the saving by drip irrigation system. Okay, so this is the entire principal network of drip irrigation system, and the first is the emitters. Actually, if you see these emitters, they are either mounted on the lateral, so these are known as the online lateral. Okay, or those are either mounted online, those are known as the online dripper, or those are inserted into the lateral line, so this is known as the inline. normally this is the lateral line. Means this is the lateral pipe which are sprayed on both the sides of the submain. So these are known as the lateral line. And on these laterals, the emitters, they are mounted like that. When those are mounted on the lateral, those are known as the on-line emitters. Okay, because these are on the laterals, and this lateral is normally made from the material which is known as LLDP, that is linear low density polyethylene, LLDP. So the material of this lateral is LLDP because this kind of the material is flexible, and when it is exposed to the sun, it doesn't brittle as well, and its life is almost 7 years. Okay, and these are the drippers which are mounted on the lateral, on-line lateral, and so some of the emitters like this, those can be mounted inside the lateral. So these are known as the inline laterals. Okay, so this is the online drippers like this. These are the online, and these are the inline. Okay, so depending on the use, we can use any one. Then for fertigation, that is applied. Fertigation means applied fertilizer along with water is known as the fertigation, because fertigation is the nutrient, and along with water, plant needs nutrient as well. Okay, so there are the devices which called as the fertilizer tank like this, or the venturi, which enables the fertilizer to flow into the system. And as I have told you, sand filter. Okay, there were 3 kinds of the filter: hydrocyclone, sand, and the disc filter. Sand filter is also known as the media filter. So this is the tank, and there will be sand which will be filled up to half level, and then water comes here. Then algae and all those things will be separated. All these are the sand filters, and this is the screen filter. This is the disc filter, which will remove even the finer impurities in the water. And this is the hydrocyclone filter, which will remove the sand which is present in the water actually. These are certain connection. Actually, we saw this as the lateral. This is made from the LLDP. So this is connected to the submain, which is made either from the PVC or HDP. When it is connected, there is special types of the connection which is required, which is known as the grommet here, because we have to connect in such a way that there is no leakage into the system. Okay, so this is all about what we call as, in short, about the drip irrigation system, which is one of the types of the micro irrigation method. Then if you see, when drip irrigation method applies water, you will see the waterfront like that. Okay, in surface irrigation method, what happens? We have to apply water over the entire field, and in that process there is a lot of wastage of water. Here water can be applied just at the right location, and so there is not allow the sprinkler by conventional or rain gun or what we call as the central pivot, only just to apply water in the root zone. It will be spread over the entire field actually. So that's why in drip irrigation method there is saving of the water. Okay, so these are the different kinds of the arrangement to be adopted. Then nowadays there is one addition to the drip irrigation method. Whatever the drip irrigation method we have seen, in that case the laterals and drippers, they are mounted over the land surface like this. We can mount those below the land surface. Okay, so in this process what happens, when water falls over the land surface by surface drip irrigation method, there will be certain loss of water because of the evaporation. But when we lay the lateral some 10 to 15 centimeter below the land surface, then there won't be wastage of water because of the evaporation. Okay, so this is additional saving of water. Then there is bubbler irrigation, which is normally practiced in some peri-urban area, wherein instead of applying the water in the form of droplets, water is brought up to the field, up to the tree, okay, in the form of, and then it is applied in the form of this jet actually. Okay, so this is basically applying water automatically by a pipe network, but not in the form of droplets. It is just in the form of jet. This is known as the bubbler irrigation. Then there is micro sprinkler irrigation method. Means when we want to irrigate the smaller field, okay, then we have the micro sprinklers, which are still cheaper than the mini sprinkler, okay, and which we can easily operate. Our micro sprinkler irrigation method can also be used for the under tree irrigation. Say, for example, these are the trees, and we can have the micro sprinkler under tree. So many times what happens, if we apply the drip irrigation method, we need 10-15 drippers per tree. So instead of that, one micro sprinkler is sufficient actually. So this kind of the under tree irrigation is used for many orchard plantation. And also when you pass just approach road to the airports and all those things, these under tree micro sprinkler irrigations, they are adopted. Okay, so this can be adopted for under tree and also over tree to irrigate like this. Okay. Bubbler irrigation I have already shown. So this is the different kinds of the bubbler, so which is just used to irrigate, provide the exact amount of the water to the tree. Okay. And then the last one is the subsurface irrigation method is there. Whatever I have told you was that the subsurface drip irrigation, and there is one method which is also come into the picture. It is the subsurface irrigation. So wherein we maintain certain water level beneath the soil or below the ground surface, and plant will take water as per its need actually. In drip irrigation method, in sprinkler irrigation method, or in surface irrigation method, we apply water to the field, and in case of the subsurface irrigation, the water level is maintained below the land surface, and plant will take water as per its need only. So that's why it is known as the subsurface irrigation. Okay. So these are the different kinds of the irrigation method, so which I just wanted to introduce to those who don't know. Okay. So in summary, what I will see that we need irrigation because of the temporal and spatial variation of the rainfall, and because water is required to the plant over its entire growth season. Okay, so therefore to store water, and when we store water, we need certain infrastructure. That store water we have to divert to the field. We need certain infrastructure, and we have to manage those infrastructure quite efficiently, and that's why we need the efficient water management practices. And there are several means for that purpose, and one of the means is to adopt proper irrigation scheduling. And one of the part of the irrigation scheduling is to have the proper irrigation methods. Okay, and then that's why I told you the existing irrigation method are conventional flooding, which need not to be practiced. Then surface irrigation method, different kinds, sprinkler irrigation method, and drip irrigation method. I tried to tell you in short about the different components of the drip irrigation method, sprinkler irrigation method, and at the same time surface irrigation method, and different versions of the micro irrigation method. Okay. And the next portion would be how much to irrigate and when to irrigate. But I think I would like to stop here and take some questions, and if there is time, then I would later on tell about how to irrigate, and at the same time not how much to irrigate and when to irrigate, because we have developed certain mobile applications for that purpose. Okay, so for the time being, at least I stop here, and I would like organizers to open this topic for the discussion. Thank you very much.
Thank you, sir. Now topic is open for discussion. I request all the participants, please drop their question in the chat box. There is one question from Alfred Kobina Wilson. What percentage of water is saved by using drip irrigation, and what percentage of yield is increased?
Okay. In fact, our experiments, because on drip irrigation method, before bringing that method into the practice, we conducted a lot of experiments, not only in India, okay, but in different countries. And all these experiments showed that at least 50% of water is saved if we adopt drip irrigation method. Let me tell 50% at what point. Okay, so when we bring water up to the field, say And if we have 100 unit of the water there, then if surface irrigation needs 100 unit of the water, drip irrigation method will need only 50 unit of the water. So we save 50% of the water at the farm. The reason, of course, is that in surface irrigation method, we have to wet the entire land, and in that process, we need the more water. And why we have to irrigate the entire land? Because water has to move over the land surface. Okay, so we cannot just by surface irrigation method bring water at the point where it is needed. It is not possible, because we have to move water over the land surface, and when water moves over the land surface, then water will infiltrate into the root zone, and some of the water will infiltrate into the root zone, and some of the water will move ahead. And while it moves ahead, that water will infiltrate into the remaining part of the root zone. Okay, but in that process, it needs a lot of water. And another thing is that as it needs a lot of water for one irrigation, second irrigation we have to apply after many days actually. But in drip irrigation method, what happens? We can apply exact amount of the water. Say if plant needs 123 millimeter of the water, we can apply exactly the same amount of water. Okay, and we can apply that water only into the root zone. Okay, so now, and as I have shown you some picture before, there is no necessity to wet the area which is not required to be wetted actually. Okay, because in between the plant rows, okay, so there is area which doesn't need any irrigation. Okay, in case of drip irrigation, for example, if you see this figure, this is the point where exactly we have to apply water, and this is the area where water is not required. Okay, so but in drip irrigation method, we can bring water exactly up at this point, and we can apply the exact amount of the water. So because of this, the 50% of water is saved. And because in drip irrigation method, we can apply water every day, sometime twice in a day or alternate day, as per the plant need. Plant is not subjected to any kind of the stress anytime, and therefore plant will grow vigorously, and there is increase in yield actually. And our experimentation show that depending on the crop, drip irrigation method can increase yield at least by 25%. So at least 50% of the water saving is there at farm head, and at least 25% increase in yield is there if we adopt the drip irrigation method properly. Thank you.
Thank you, sir. The next question
Sir.
is from
Hello.
Please, ma'am.
Sorry to interrupt you.
Yes,
Yes, you carry on, then I'll ask my question.
Yes, ma'am.
Okay, madam. Okay.
The next question is from Dr. Mintu Job. Does PC emitters work on laterals laid uphill side, or does in such case it provide uniform discharge at the far end?
Okay, let me tell you, for those who may not be knowing, because, okay. Yeah, if you see this particular layout of the drip irrigation method, okay, if I consider this as the one unit, if you, and the laterals may be many in numbers, and on each lateral there are drippers. Those drippers may be many in numbers. Okay, in drip irrigation method, what happens? In generally, we provide certain pressure here. Okay, and when water comes here, that pressure drops down. Okay, let me tell you one fact. Normally, to apply water in the form of droplets through drip irrigation method, we need to maintain certain pressure at the dripper. Okay, so because this dripper will ooze water in the form of droplet. Okay, and for that, the dripper is designed in such a way that it needs certain pressure at the dripper. Normally, that pressure is 1 kg per centimeter square, or it is known as the 10 meter. Okay, in terms of the pressure unit, it is 1 kg per centimeter square. In terms of the meter unit, it is 10 meter. So 1 kg per centimeter square pressure is to be maintained here. Okay, so our entire drip irrigation system is to be designed in such a way that the 1 kg per centimeter square pressure or required pressure is to be maintained here. And for that, we have to calculate what pressure is required here. Say, for example, here say if 1 kg per centimeter pressure is required at this dripper, then maybe at this point, some more pressure is required. Okay, because when water is flowed from this point to this point, this flow of water needs certain pressure because this water has to resist the frictional head losses. Okay, so for example, if pressure requirement here is 1 kg, the pressure requirement here may be 1.2 kg. Okay, then the pressure requirement here may be 1.5 kg. Okay, because when water flows, as I have told you, when water flows through the pipeline and inner material of the pipeline is not the ideal surface. Okay, so it is the real surface, and when water flows, it has to overcome the resistance which is offered by the resistance. It needs certain energy. Okay, so that's why to get 1 kg pressure here, we have to maintain 1.2 kg here, we have to maintain 1.5 kg here. Okay, so this is just example, and then maybe we have to maintain 1.6 kg here, and there is one filter, so at this point maybe we have to maintain 2. At this point I may need 2.5, at this point I may need 3 kg, and then at this point I may need 3.5 kg pressure, and if I have to take the water from certain height, I have to maintain here 4 kg pressure. Okay, so this is known as the design of the pump. So to get 10 meter up, to get water at 10 meter pressure or 1 kg pressure, I have to have here 4 kg pressure. So this means that when water oozes or water is pumped at 4 kg, here we get 1 kg. Now, there are the normal drippers. What will happen, those drippers, what those drippers do, and again, as per the principle of hydraulics, the discharge is proportional to the pressure. Okay, so if pressure is more, discharge will be more. If pressure is less, discharge is less. Okay, so as I told you, if 1 kg centimeter square pressure is there, then here there will be slightly more pressure. Here there will be slightly more pressure. Here there will be slightly more pressure. Okay, because here pressure is 1.2, so the discharge here is more. Here pressure is less, say maybe 1.1, discharge is less. Here pressure is still less, 1.05, discharge is less. And here if say pressure is 1, the discharge is less. Okay, because this is the hydraulic characteristics. So what happens in that process, the water will be applied more here and water will be applied less here. Okay, but these are the normal drippers which are called as the NPC dripper, that is non-pressure compensating. Okay, so whatever the pressure exists on the pipeline, that pressure is there. Okay, but when we use such kind of the non-pressure compensating emitter, there is variation in the discharge as well. Okay, and that variation, the system is designed in such a way that that variation in discharge is not more than 5 to 10%, but still there is variation in discharge. Okay, but there are certain kind of the emitters. Okay, there are certain kind of the emitters in which the arrangement is made in such a way that, okay, if we vary the pressure to the certain extent, the discharge is same. Okay, for example, here the pressure is 1.2, here the pressure is 1. So the pressure is varying in the range of 1.2 to 1.1 kg per centimeter square. Okay, inside the dripper, one diaphragm arrangement is made in such a way that even if the pressure varies in that range, the discharge is same. That is that is at every point I will get the same discharge irrespective of the variation of the pressure. So this is known as the PC drippers, that is pressure compensating drippers. Okay, the question was that pressure compensating discharge, if we adopt those to the uphill, okay, so what will happen actually? Normally pressure compensating emitters which are available in the market, they are designed in such a way that if the length of the lateral is up to 100 meter, then for 100 meter, the emitters which are connected to the laterals over 100 meter will give the same discharge. Okay, this is on the, what we call, this is on the flat land. But if there is a uphill, then for uphill, if the pressure is up to, if the slope is up to 3%, then we have to make the length of the uphill lateral less, that is 80 meter only. Okay, instead of 100 meter, we can make 80 meter, and in that case, the pressure compensating emitters will work as per its principle, that is providing the same discharge for the pressure variation. If it is more than 3% slope, 3 to 5, then we have to make that length as the 60 meter. Okay. And if it is more than 5, then we have to make that length as the 50 meter. Okay. So generally on the level land, if we keep the length of the lateral with pressure compensating emitter up to 100 meter, we get the same discharge, uniform discharge, which is one of the strength of the drip irrigation method. But if there is slope, then depending on the magnitude of the uphill slope, we have to reduce the length of the lateral to make the PC drippers give the same discharge at every point. Okay.
Thank you, sir. Now I request Dr. Daya madam, please ask question.
Yeah, thank you, sir. It was a wonderful presentation, so much educative and informative. Many things have been cleared by now. Really thankful to you. Sir, I just wanted to ask some things which always comes in front of the farmers while using the drip and sprinkler. So many a times the farmer is gets confused that which one is better for the vegetable crops, or whether it is drip, should be only drip, or should be along with the sprinkler. And if so, then how to operate both at the same time or at what interval? This is my first question. Secondly, for this area, for example, Rajasthan and the areas which have more of sandy and sandy loam, which method is better? It is subsurface or on surface drip usage?
Okay. The first, madam, thank you very much for your nice words and questions as well. The first was, I think, whether to use, when to use sprinkler and drip, right?
Yes.
Okay. Now, first of all, sprinkler irrigation, if we see the principle of the sprinkler irrigation, it is application of the water over canopy actually. Okay. It is application of water over canopy. And in case of the drip irrigation method, it is application of water into the root zone. So this is the basic difference between these two. Okay. Normally, sprinkler irrigation method, we can adopt, okay, to almost all the crop, excluding of course paddy and jute, okay, paddy and jute, okay, and except the orchard plantations. Okay, in orchard plantation, we have to adopt the sprinkler irrigation method in a different way. Okay, otherwise we can adopt sprinkler irrigation almost for all the crops. Okay, but there are certain crops wherein if we wet the canopy at certain stage, then it is hazardous for the plant growth. Say for example, what we call as the chickpea. Okay, so at certain stages, if we wet the canopy, okay, then the sprinkler irrigation becomes harmful. Or if we use the flowers actually, and at certain stage, if the canopy including the flowers is wetted, then we may not get the good quality of flower. So for that, we need not to use the sprinkler irrigation, but sprinkler irrigation method we can use for almost for all the field crops actually. Okay, row crops and close growing crop basically. Okay, so such as wheat is there, onion is there, such kind of the crop, or soybean is there. So we can use groundnut is there. Okay, so we can use sprinkler irrigation method. But in sprinkler irrigation method, the entire canopy is wetted, and farmer has to remember that not to operate the sprinkler irrigation method during which if the water falls over the canopy, the crop is damaged. So that is one thing. And we cannot use sprinkler irrigation for the crop which needs certain kind of the ponding, such as jute and paddy. Now, in case of and also sprinkler irrigation method is not that applicable for the orchard plantation. Now, when we comes to the drip irrigation method applies water into the root zone. It is not the over canopy irrigation. Okay, so it applies water into the root zone of the crop. So therefore, drip irrigation method can be used almost for all the crops. Earlier, there were speculation that whether we can use the drip irrigation method for paddy or for jute. But if there is upland rice, okay, then we can use drip irrigation method for upland rice. That is the rice where we don't need any kind of the ponding. Okay, or as such, we can use the drip irrigation method almost for all the crops. including the field crops, including the orchard plantation. But one of the limitation of the drip irrigation method is that if we use it for the close growing crop, like say wheat, onion, and all those things, okay, so we have to have the lateral lines, that is these lines, okay, so these lines closer actually, because those are close growing crop, okay, so we have to bring those lines to the closer, and the expense on the drip irrigation system may increase, okay. But if we use the vegetable crop, then we can modify the crop geometry to a certain extent, in which case we can bring two rows of the crops together. Say for example, this is, okay. So in this case, say this is the cabbage. In cabbage, two rows of the plants, they have brought closer, and there is only one lateral for two rows. There is only one lateral for two rows, okay. So in that way, we can save the cost on the system, but it may not be possible for wheat, garlic, and onion. So though we can principally adopt the drip irrigation method for those crops, it becomes expensive, but still the farmers in many regions across the world, they are using drip irrigation method for close growing crop as well, okay. So I think this is the answer to my first question, your first question, my answer to your first question, sorry. And the second is, when the soil is sandy or loamy or very light soil, then what to do? In that case, what we have to do, there are many other ways, but when we have to adopt the drip irrigation method under such system, then in case of the sandy soil, we cannot use the dripper having very low discharge, and we cannot use the dripper having very high discharge. What happens if we use very dripper having very low discharge, then all the water in the sandy soil tends to evaporate actually, okay. And if we use the dripper having a high discharge, then the water will just percolate straight away out of the root zone, okay. So root zone won't be wetted much, okay. So when we use the drip irrigation system for sandy soil, then our discharge should be from 2 to 4 liter per hour. That is one thing. And our dripper should be closely spaced. For example, if in case of the heavy soil, normally the spacing between two drippers on one lateral is 2 feet, 60 centimeter, or 2 to 2.5 feet. Okay. But in case of, this is the, say for example, this is heavy soil. In heavy soil, the spacing between two drippers can be 60 to 75 centimeter, because in heavy soil, when water drops over the land surface, okay, then its lateral movement is more, and one dripper can wet the more bulk of root zone compared to light soil. In light soil, what happens? Here I have shown here. Here it is the heavy soil. In heavy soil, you see the lateral movement is more. In sandy soil, vertical movement is more. Okay. So that's why its discharge of the dripper should be 2 to 4 LPH. And at the same time, as the lateral movement is less, in case of the sandy soil, dripper needs to be closer actually. Okay. So we say that in sandy soil, the dripper needs to be spaced at the 30 centimeter, whereas in case of heavy soil, it can be from 60 to 75 centimeter. So when we use drip irrigation system for sandy soil, we have to use 2 to 4 liter per hour emitters. And at the same time, the spacing between two emitters should be as less as possible, not more than 30 centimeter. Then third case is that when we use the drip irrigation system for orchard plantations, for orchard plantation, normally the number of emitters, they are less. Say for example, if you are growing, say oranges or say pomegranate in light soil, and you are growing the pomegranate in heavy soil. In heavy soil, normally 3 to 4 emitters are required per pomegranate tree plantation, whereas in sandy soil, those are 6 to 8. So normally what farmers tends to use, they tends to use the less number of emitter even in sandy soil. If we use the less number of emitter in sandy soil, then the entire root zone cannot be wetted, because with less number of sandy soil, we irrigate with less number of drippers in sandy soil, the wetted area by each dripper is less, and we may not irrigate the entire land, okay, entire root zone. Okay, so in sandy soil, we have to take care while using the drip irrigation method for orchard plantation. We have to use the more number of drippers compared to the sandy soil. We have the configuration for each kind of the plantation regarding the number of emitters and regarding the discharge of the emitters for heavy, medium, and sandy soil or light soil. So this is one example. Another thing is that many times we advocate for sandy soil or light soil. Instead of using the drip irrigation system, we can use the under tree micro sprinkler irrigation system. Okay, under tree micro sprinkler means instead of using 10-15 emitters per tree, because for oranges we need in sandy soil 10 to 12 emitters per tree. Okay, so instead of using those many numbers of the emitters, okay, per tree, we can use one micro sprinkler like this. Okay, so there is only one micro sprinkler. So this is known as the under tree micro sprinkler or under tree sprinkler irrigation system. This is the under tree. So let us go for the under tree sprinkler irrigation system, which is very efficient for irrigating the orchards in case of the sandy soil. So in nutshell, for your second question, if we want to go for the field crop in sandy soil, use the emitters in the discharge of 2 to 4 LPH, have the spacing between emitter less than 30 centimeter. That is one thing. For orchard plantation, use more number of emitters. Okay, so if you want to use the oranges, for oranges having 6 meter to 6 meter spacing, we have to go for 10 to 12 emitters in case of the sandy soil, and you can have particular such kind of the emitters that is applying in the ring in case of the sandy soil, or you can go for the under tree irrigation, under tree micro sprinkler. Then regarding using what we call as the subsurface drip irrigation when the soil is loamy to moderately sandy, I will advocate to use the what we call as the subsurface drip irrigation method, because it will save anyway 10 up to 10% of the water, and in those soils it is also easy to install the subsurface irrigation. Thank you very much, madam. I hope your query is solved. Otherwise, you can ask. Yeah.
Thank you very much, sir. It was wonderful.
Thank you, sir.
Yes.
Next question is from Dr. Sanjay Vanjari, sir. Dr. P.D.K. Vyakula. In urban area, quality of irrigation, as most of them are using corporation water, that water is having chlorine and salt. So that water can affect vegetable and plants.
Yes, you adopt any irrigation method. Okay, if there is one water quality chart actually. Okay, irrigation water. What we call the agricultural produce of in a safe zone. It is different for leafy vegetables. It is different for fruit vegetable. So we have to use the water of that quality only. Okay. Otherwise, what will happen? You use any irrigation method. Okay. Then those impurities, especially lead and all those things. Okay. So those can enter into the leafy vegetable, which may be hazardous actually. Those can also enter to some extent in fruit kind of the vegetable. Those are also hazardous. So when we use any irrigation methods for peri-urban or urban agriculture, okay, then we have to give proper attention to the water quality, or alternatively, there are several means to treat that water, okay, up to the level which we can use for irrigation. And if we irrigate the plant by that water, we can consume its product. Okay, so but we have to be very careful. And as far as the salty water is concerned, in case of the surface or sprinkler irrigation method, as the irrigation interval is less, actually more, that is we apply water after many number of days, and then when we apply water, then normally at that point the water tension is less and plant can take water. But when during the but after 10, 15, 20 days, then water content in the soil is less and therefore tension is more, and if it is salty water, then plant has to exert more stress, and which is not possible for the plant. Okay, and therefore when using surface irrigation method with salty water, then it becomes problematic. But in case of the drip irrigation method, we tend to apply water every day, alternate day, or in between 2 days, and we keep the water content in the root zone normally at the field capacity. Even if the salts are present to some extent into the root zone, plant doesn't have to exert much. And in case of the drip irrigation method, we can use the salty water to some extent without any problem.
Thank you, sir. The next question is from Dr. Prasad Kulkarni. Whether crop coefficients inside the protective structures varies as compared to open fields.
In fact, let me tell, because I was having the second part of my lecture on that, but anyway, you asked the question. Crop coefficient is in fact same actually. Okay, crop coefficient is the characteristics of the crop, whether you grow in any environment. Okay, whether it is open, whether it is protected, whether it is irrigated by drip, whether it is irrigated by surface. Okay. It is the natural, but when you grow in the protected environment, okay, then the evaporation and transpiration is affected. Okay, crop coefficient remains same. Say for example, in case of say today's crop coefficient is 0.8 and evapotranspiration, reference crop evapotranspiration is 10. Then we'll have to apply 8 mm of water. Okay, but in case of protected cultivation, its crop coefficient will be same, but its evapotranspiration requirement will definitely be reduced actually. Okay, and because of which the crop water requirement will be reduced. Okay, and for this purpose, what I would like, I would like you to refer to our Fule Jal and Fule Irrigation Scheduler mobile apps. Okay, what those apps give, app provides you when to irrigate and how much to irrigate by surface, drip, sprinkler, irrigation method, orchard plantation and field crops, under open field condition, under polyhouse, under shade net house, and also under mulching. Okay, so and we have given the values of the crop coefficient inbuilt in those apps. Okay, so you can also refer to those mobile apps. Those are available in Play Store. Maybe I will request Dr. Davi to provide the links to those apps as well.
Yes, sir. Thank you, sir. The last question is from Safal Rai. Can drip irrigation method adapted on very deep-rooted plants?
Yes, it can be, no problem. Only thing is that in drip irrigation method, we have to take care that we wet the entire root zone. Say for example, what happens in case of drip irrigation method, if we don't apply water by chance by say continuous 1 month, okay, and after 1 month just we are for 2 hours. Okay, so in that case, if it is the deep rooted plant, okay, either already much portion of the root zone is dry, and if we apply less water as per the requirement of 1 day or 2 days or 3 days, then there will be a problem. So when we normally we advocate that in case of the deep rooted or tree plantation, if you are using drip irrigation method suddenly, make sure that you first irrigate, your first irrigation is up to the field capacity. Okay, so that is depending on the type of the crop, type of the soil, you have to operate the system for 18 to 24 hours continuously, and after that you can start applying water as per the drip irrigation schedule.
Thank you, sir. Due to the time limitation, we have taken only some important questions. Later on, we will share the remaining few questions with the expert and we'll give answer. Shall we move to the vote of thanks, sir?
No problem for me.
Okay. Thank you very much, sir, for such a nice informative presentation regarding advanced technology in drip irrigation system for the urban farming. I am also thankful to Dr. Rohi Dahiya madam, who is the Vice Chancellor of Jayoti Only Women's University in Jaipur. Last but not the least, I am also thankful to all the participants who kindly attended the session very patiently. And now, with the permission of the organizer, I am ending the session here. Our next session will be at the 3:30 p.m. and link for that session will be shared half an hour before in the WhatsApp group. Now, after half an hour, I will share the quiz link. Please submit quiz response within half hour after posting the link. And the submission of quizzes and attendance is mandatory for all the participants. Please note. Thank you. Thank you all.
Thank you.
Thank